that will be coming up in the next few months. This is a topic that we were discussing with the ESIG planning group. The users group meets twice a year. Our next meeting is coming up in October, where we discuss, amongst other users of wind turbines, solar, or energy storage, the issues that are coming up. And this is definitely one that we discussed as a hot topic for our next users group. But we felt that since the due date on a lot of this is January 1st, that if someone was hearing this for the first time, that would not give them very much time to prepare for this. So that we'd let this information out a little earlier with this webinar. We have a pretty powerful group of speakers today. We're going to be focusing on 6 topics today. First of all, with Joseph Baxter from NERC, giving us a history of CIP 3 version 7, how did we get to this point, and breaking down CIP 3 version 7 into 5 topics. Craig Reeds will be discussing cybersecurity awareness. Kennings, physical security controls. Electronic access controls by Alan Kent, as well as cybersecurity incident response. Back to Craig Reeds for transient cyber assets and removable media. A couple things to note on this before we get started. If you hear some information here or weren't able to remember exactly what was discussed, this will be recorded. This will be emailed out to anybody that has signed up for this webinar. Considering this is Friday, that'll be something that will be in your inbox early next week. A couple other things to point out. Again, we have a pretty powerful group of speakers here. If you want to follow up with them, when you do get the copy of the webinar, all these email addresses will be available if you want to follow up with any of these speakers after this webinar. Finally, the goal here is roughly a 60-minute presentation, 10 minutes on each topic, and then a QA period at the end of it. With as many people that are on this webinar and as many speakers as we have, if you have a question, please list the topic, for example, physical security controls. That way we'll know to direct that question to Neil. Another thing to keep in mind, just in case there's any hesitancy in asking a question, you're unsure if you should ask this question, this will be anonymous. Questions will be typed in. I will read that and direct that to each of the speakers. So that being said, let's go. We'll start off with the history of CIP 3 version 7 with Joseph Baxter.
Hello, everybody. This is Joseph Baxter from NERC. I'm a senior CIP assurance advisor. I've been at NERC for about a year and a half. Before that, spent a lot of time in the industry from a major global provider. Also as an auditor in the southern regions, in the CERC region. So been around. I've also been on the other side of the table as someone like yourself, in your shoes, actually putting together a CIP program and being audited. So I've been in this industry since about 2008-ish. And the one thing that you may or may not be familiar with, depending upon your location of the company and whether you as an entity have ever had to do CIP compliance, maybe you have other departments or other branches or business areas of your enterprise that does do CIP compliance, maybe in a control room or in transmission. That being as it may, if you're not familiar with the CIP standards, I want to give you a little background and just the way the whole thing works together, just to set the stage for the other people coming up in the presentation. Version 1 went compliant in various stages. It actually was unique. I don't think any of the engineering requirements or standards did this, but back when they were approved by FERC and by the board, they actually had multiple levels of compliance. There was substantially compliant, there was compliant, there was auditably compliant. So the idea was if a requirement that required you to do something once a year, it would go compliant on July 1st of this year, and then it would be auditably, or to be able to be audited, the 1 year later. So it had a kind of a graduated or progressive type of compliance going in. So you don't have to deal with any of that. My very first audit that my entity where my neck was on the line, went for, we had the 13 original CIP compliant or CIP requirements that we had to be audited for. And it was very rough because nobody knew really what that looked like. So you don't have to deal with that. And in version 3, things changed a little bit. They got better. Version 3 was probably a very good version of the first 3, where things got straightened out and things made a lot more sense. Now, version 4 never saw the light of day of the CIP standards, what we call version 4. But that introduced something called the bright line criteria that has gone forward into what is now referred to as the impact rating criteria in the later versions. You will see, though, people will still say bright line criteria. Really, all that is what you're very familiar with already, is that, you know, there's megawatt values put on power plants. There's MVAR values put upon substations, things like that are just, they're hard and fast line that if you are this, then you're under consideration for a high. If you're that, you know, you may be in the medium, or in the case of many of the wind and various renewables, you might be down below impact. But there's still things to do, as you well know. Version 5 had a much longer life. It stayed around a lot longer as we're moving away from it now into standards that are rated or versioned at 6 and 7. We added in version 5 CIP 10 and CIP 11, 11 protected information, which used to be down in CIP 3. Also CIP 10, which was change management, which used to be in CIP 7. So we've expanded that a little bit, made things a little bit more granular and a little bit easier to, I would say, more bite-sized chunks, if you will. 14 and 12 coming along very quickly. Of course, version 7 of the CIP 3 standard coming along. And these things are gaining maturity. Case in point, once upon a time, CIP 2 talked about routable connectivity, and then CIP 5 would say communications. And many people got themselves into trouble by saying, well, we only care about routable, and then they would get into issues when they got into CIP 5 because CIP 5 didn't say routable, it said communications. And that would include serial communications. Now, this is, of course, in previous versions. As the standards have gone forward, they've matured. A lot of that kind of gotcha or the unexpected consequence factor has been shaken out. They've gotten better. The drafting teams have picked up a lot of feedback. They've seen these things happen. What they wrote and what they intended may be two different things, but they're getting much closer now. Just remember that really what we're looking at is you've got sites that might be part of the bulk electric system. Those bulk electric system sites or facilities may include cyber assets, bulk electric system cyber assets. How do I find that out? Well, I put them all on a list. I can do that in Excel. I can do that in some really nice tools that various people sell and maintain. But the reality is each system or each asset as part of a system must be assessed whether or not it has a 15-minute impact, operation, misoperation, whether it's adversely, whether it's there, whether it's present, or whether it's misused. That's really what it comes down to, and that's what that's the list that you're creating that will go into CIP 3. So all of your low impacts based upon that list are going to have a 15-minute impact on the bulk electric system. That's really the break-even point where you've got to do something versus it's not in the bulk electric system and is not a cyber system in the bulk electric that affects the bulk electric system. The systems are literally just a group of assets. I would say make those very rational. Make them. Don't make the auditors ask questions about why these things are grouped together as a system. Just make them rational. Anything that you go into an audit with, you want to be able to pass the red face test. When you are describing something to somebody else, it's not embarrassing. You don't want your face to go red because of something that you did that sounded great. They got you out of a lot of trouble at one point, but then when you have to describe it later, it's kind of hard to do. So make sure that all of your determinations there, all of your decisions, when you're joining these things into systems, when you're looking at things as you go into CIP 3, even with your low impact BES cyber systems, that they will pass the red face test. One of the best resources we found over the course of my entire history with the CIP standards, when I was under compliance and then when I was performing monitoring on compliance, and now that I'm monitoring the people who monitor compliance, one of the best resources we found is your peers. Don't be afraid to talk to people. I call that the spirit of coopetition. Everybody's a little bit in this together. We're all very connected in the bulk electric system, so reach out to your peers. Build tools. They don't have to be fancy. A spreadsheet sometimes works for a smaller entity, and then there's really fancy things too. It doesn't matter what it looks like. Matter of fact, I tend to tell people you don't really know until you know what you're looking for. Buying something at the beginning, you might not exactly know how you want to run your CIP program yet, so it's sometimes difficult to know what that program is really supposed to look like. Google is your friend. Even at NERC, we look for our documents based upon Google. That might, you might find that funny, but also it's interesting what else pops up there, and that's something that we at NERC try to really keep a close tabs on what else shows up when we're doing searching for things. But Google is your friend. There's a lot of presentations out there. There's a lot of track record in the CIP standards out there. You'll be surprised what you find if you just do some searches on CIP standards and the ways they have been implemented. And with that, I'm going to pass the ball over to Mr. Craig Reed.
All right, thank you, Joseph. Now, time to dissect the different topics of CIP 3 version 7, starting off with cybersecurity awareness with Craig Reed.
All right, thank you. Okay, so let's start off with quick, who am I and why am I here? My name is Craig Reed. Got a couple of different cybersecurity certifications. I work for a company called Electric Power Systems International. I'm their NERC CIP senior consultant and their cybersecurity compliance manager. I've been in cybersecurity for over 30 years and came to the NERC dark side about 5 years ago, and have worked with high, medium, and low impact facilities. And then also I've written multiple articles on both NERC compliance and cybersecurity. So that's who I am. All right, so cybersecurity awareness. So according to the regulations, at least every 15 months, you're to train your employees on the correct cybersecurity practices and cybersecurity policies and procedures for your organization. Now, for the best results, cybersecurity awareness training should not be done like once a year. This is something that should be done, almost on a daily basis. Having posters on the wall, sending email reminders once a week. There's even a utility that I've worked with that has a post-it notes that all the employees have on their desks that printed on the post-it note is, don't write your password on this. So it kind of is this daily reminder of cybersecurity and that awareness and everything. You want to make sure that your training is specific to your people or your organization. If you're talking about certain things that say an operator isn't going to be faced with every day, they'll kind of tune out, not hear the stuff that they should hear. So it's important that you drill down and make this specific to your organization. You can't just go out and grab a cybersecurity awareness slide deck or whatever from off of a website and bring it down and show it to everybody and expect it to mean anything to everybody in your organization. And then, of course, since this is NERC, evidence of compliance is important. I used to work with a gentleman who said, if you don't have evidence of compliance, you didn't do it. So, and this evidence of compliance can be emails, it can be memos, it can be the actual presentation that you used, dated presentations, dated documentation, dated sign-in sheets, for the people who attended the training. That kind of thing is what would make up the cybersecurity awareness, documentation and that kind of thing. So, remember that documentation is the important part of this whole thing. Okay, so pass it on to physical security controls. And Neil?
Actually, if you can pass the ball up to me, I'll run through this slide.
It is.
All right, next up, physical security controls. Neil Kennings will discuss that portion of CIP 3 version 7.
Thank you. I'm Neil Kennings with DTE Energy. We're going to cover CIP 3.7 physical security controls. Requirement 1 requires that all responsible entities have physical security policies that address low-impact cyber systems, specifically physical security controls. And then it goes further under Attachment 1, Section 2. We're required, each responsible entity shall control physical access. And the important thing here is based on need as determined by the responsible entity to the asset or the locations of the low-impact BES cyber systems and assets. So NERC has been is kind of vague on this, and that's a good thing because it provides us a lot of flexibility and latitude to develop our own physical security programs and plans. However, it also means that we must be able to explain and or defend in an audit how we came up with our program. Next. So here are some recommendations, things that we've done at DTE over the years, things we've learned. Not telling you what to do, just relating some of the things that we've learned as we've gone through this process over the last several years. The first thing that we do is we determine and identify the locations of our BES cyber systems and cyber assets that we intend to defend. Once we've identified those systems and assets and their locations, then we conduct a physical security risk assessment of the facility that houses them. And then based on that risk assessment, we either create or follow an existing physical security control plan. Now, when you have like I said before, you have a lot of flexibility in creating this, but when you do that, be prepared to explain the physical security standards or specifications that you've developed. Be prepared to explain how you came to those conclusions. Some of the things you can consider are, utilizing experienced personnel from within your organization or from outside. You can also utilize, the American Society of Industrial Security has different security criteria out there. They don't, not necessarily for utilities, but for example, fencing, something as simple as fencing around a substation. As is has a standard that they use for industrial security. It's readily available. Department of Homeland Security has different criteria that's readily available. State Department and Department of Defense. I came from Homeland Security, so when I started doing physical security at this company 15 years ago, a lot of the things that I incorporated were things that I was familiar with from DHS. And then also make sure that you address how you're going to respond to physical security system failures. If you have technology you're utilizing and it fails, what will you do to mitigate the risk until you can get your systems back up and running? It could be something as simple as something as non-technical as a tree falling on the fence around your substation. What do you intend to do there? Do you have a guard respond and stand by, a substation operator, a wind tech? You just think about what you're going to do if something fails. We use a system that we call Access Granting and Revocation Tracking System. And what I'm getting to there is have a way of granting and revoking access. How do you decide who gets in, who gets out to the areas where you have your BES cyber systems and assets? What we do is, before we grant access to those areas, even though under low impacts they're not required to have PRAs, we do personnel risk assessments on anyone that we give a key to that would allow them access into those areas. So once again, be prepared to explain what your process is. Also, in terms of revocation internally, If someone leaves the company or no longer needs access, even though it's not required under Lowe's, we revoke physical and cyber access within 24 hours. Key control process, very important. You know, if you're granting keys or any type of access to your cyber systems and assets, make sure that you have once again, in addition to the personnel, make sure that you're able to account for how you issue keys and how you revoke keys. And then diagrams. Diagrams are a great way to start. They provide clarity when you're designing a plan and also when explaining a plan. For instance, for us with our wind parks, I'm required to provide our corporate NERC compliance office with diagrams that have all of the locations of all of our turbines, our pad mount transformers, junction boxes, fiber handholds, they want to know where all those things are so that if I'm being audited internally or externally, we can provide that to an auditor, and you know, it shows that we know where all of our equipment is located. Next, so some things to consider. Once again, certainly don't expect anybody to do all of these things, but these are things that we've considered over the years. Starting, you know, for wind parks, we start at the turbines and we'll work our way into the substation. One of the things that we've done, I know it's a cyber security thing, firewalling at the feeder level, but what we've done is we firewall our feeders. Each feeder feeds into a firewall in the control house of the substation. And the reason we did that is most wind parks, when they're designed, if you break into one wind turbine and you plug into the system, you can control the entire wind park from one turbine. And we thought that was quite a risk. So what we've done is we firewall at the feeder level, and now we don't have to provide as much physical security at each turbine as we would have if we had not done that. Because now if you break into one of our turbines, you can only control the turbines on that one string. So obviously you should have some sort of locking mechanism on the turbines, key locks, cyber locks, card readers. We use cyber locks on all of our turbines. It leaves a monitoring, we can do an audit trail on those. We can change, if someone leaves the company and takes the key with them, we can easily recode all of the keys and the turbine doors. So there's a lot of advantages there we found. Logging visitors and escort policy. Once again, think about who you're going to let into your turbines and how, you know, what criteria are you going to use to allow them in, and how are you going to provide keys to people. Once again, with us, we don't provide a key to anybody unless they've had a background check and the CIP awareness training, and then we do some escorting also. So think about what you want to do there and make sure you have a plan and write it down. It's been suggested to us in the past about contact alarms. You know, we have 400 turbines. You know, if you have contact alarms on the doors of those, you better have a response plan to respond to them. And then, you know, cameras, think about it. You know, once again, that's something you'll have to consider. And then monitoring, from a monitoring perspective, if someone does break into a turbine and they do plug into the system and start operating that turbine in an unusual way, your control center should notice, you know, things that shouldn't be happening electronically on that turbine. So that's a good way to, at least you have some monitoring out there. You're not operating blind. Next, please. Collection system. Once again, be prepared and write it down. How are you protecting your entire, you know, how are you providing physical security for your entire wind park? So the next part would be your collection system. Obviously, the collector system is in cut-resistant cable. It's very, you know, several feet down. In our case, at least 5 feet. Then your fiber conduit, usually our fiber conduit runs generally along the same path as our collector system. It's in conduit 5 feet below the ground. One thing you want to think about when you're thinking about fiber conduit, once again, a lesson learned for us, is that if your fiber is running above ground, try to put it far enough above ground where somebody just can't walk up to it and cut it. We did run into, after we completed building a couple of wind parks, we found that there was some of the fiber had been run maybe 4 or 5 feet in the air in certain places, and anybody could have walked up and just cut it. So if you're going to have it above ground, try to get it up as high as you can, so at least someone would have to use a ladder. Junction boxes, once again, ours are at 34.5 kV. We just make sure that they have some sort of lock. We use hard locks and or cyber locks depending upon their location. And one of the things that we found was the fiber handholds. This was a lesson learned for us. As we were out inspecting our junction boxes, we noticed that next to each junction box was a fiber handhold buried in the ground, and it wasn't secured. So we pulled the top off, and sure enough, there was our fiber that was running to our wind farm management system, and all it would have took for us to take out that whole feeder would have been to just reach down with a pair of wire cutters and just cut the fiber. So we secured our fiber handholds. We went out and we located where each one of them was, and we secured those. We used this proprietary lock because we found it wasn't as easy as we thought, just using hasps and locks. But take a look at your fiber handholds. I'll bet that when they're built, most people don't secure them. Substation, pretty standard things. Well, obviously, you're going to have a fence around it. Once again, how tall is your fence? How much barbed wire are you putting on top? And how did you come to that conclusion? What criteria did you use? Keys, once again, either hard keys, cyber keys, those kinds of things. Next thing is your control house, obviously. Once again, you're going to have either hard keys, cyber keys. We use a combination of both. Monitor who's going in and out. Nice thing about CyberLock is there is a audit trail, but we also have our logs inside the control house, and we do use intrusion detection on one facility that we share with a third party, and it's the same thing with cameras. We don't use that really in one location. Use them as you deem fit based on your risk. One other thing we do is once you're inside the control house, consider where your wind farm management system and or your firewalls are. We've taken those and we've put them into a special lockable cabinet, and we provide one additional layer of security where we have card readers on those racks and those racks only. So, and we have very, very limited unescorted access into those racks. So that's an additional layer of security for us. And then Met towers. One other thing to remember, sometimes we miss these, is that if your Met tower has fiber that feeds back to your wind farm management system, then you want to be able to protect that physically also. So obviously you have fencing, keys, locks on that fence. And then what we do is usually there's somewhere between 2 and 4 different cabinets on those Met towers. Look in those Met towers, find out which equipment in there it could communicate with the wind farm management system, and make sure you put an additional layer of security. We put cyber locks on those also.
Thank you very much, Neil. Next up, Alan Ken Jr. with NAES. He's actually going to cover 2 topics in a row here: electronic access controls and then cybersecurity incident response. Let me pass the ball to Alan.
Okay, thank you. Hello, everyone. I'm Alan Kent. I'm a NERC CIP specialist with NAES Corporation. My background is primarily in information technology support, including physical and cybersecurity. I've been managing NERC CIP compliance in the generation sector for about 8 years now, the last 2 with NAES. NAES is a leading third-party generation operator, and for more about our services, you can go out to our website, naes.com. I used to teach college, so I ask everyone's permission or forgiveness because some of my slides get pretty busy. But as Bjorn said, they'll be available later this week or next week. Some of the things I want to talk about today are what does permitting only necessary inbound and outbound electronic access actually mean? Some identifying where those electronic access controls are actually needed. The documentation to show how we're in compliance, and this is also for self-assurance because we might want to go above and beyond compliance and actually think of security. And then also little blurbs about dial-up and making sure we have identified our modems and how we're securing those, and then a recap of cybersecurity incident response. So the requirement says that an entity must permit only necessary inbound and outbound electronic access. To understand what that means, we must understand a little bit about networking and a little bit about firewall functions. Now, there are other ways to control electronic access than a firewall, but a firewall device is the most standard way to do this. So that's the focus of my discussion. A firewall is meant to route authorized network communications from one network to another or to multiple networks, kind of like what the post office does in that middle diagram there. You send a letter to Mary. It might be in Issaquah, Washington, might be in Boston, Massachusetts. Network communication is initiated by one machine, known as a client on the left, and then it is answered by another machine known as the server on the right. And it goes across the network to a specific port. So we have a source port, a destination source IP, a destination IP, and a destination port that are key in our discussions for firewall rules that we'll talk about. This client-server relationship is not meant to be confused with the operating system type. So a server operating system doesn't necessarily mean server. Client operating system doesn't mean client. We're talking about the relationship between the two devices here. The firewall remembers current conversations and allows responses back that were authorized. This is called stateful. Now, this differs in a router because most routers are not stateful. So the rules in a firewall set are going to be a little bit different than if you're using a router. But we're going to, again, continue to focus on firewall. On the far right diagram, you see, unlike a mailman that's going to, let any piece of mail go back and forth, the firewall doesn't let just anyone communicate with a protected network. It blocks communication that's not authorized. The firewall must be programmed with rules, and these rules are known as access control entries, or ACE, and they're found in the device configuration in a list known as the access control list, ACL. So when you hear ACL, you're talking about the firewall rules. To properly implement these electronic access controls, the rules must be exact to just the devices in the communication and what protocol or service they need to talk to. Those three things I mentioned before: source IP, destination IP, and the protocol or the port that's going to be used. Step one in assessing our security electronic controls for CIP3 is to identify where all the communication crosses an imaginary boundary around your facility. Depicted here with that dotted red line. Just like you guys don't, in the wind energy sector, you guys usually don't have a fence around your facilities. Maybe think of a building. The building has doors, maybe a garage door on the building. If I want to secure that, I'm really going to focus on those doors. So what we're looking at is the perimeter of our electronic access. What communication crosses that? We want to identify it all. Consider all the firewall devices and the routers that you have on your premises first, and add them to a diagram as a start. A high-level diagram such as the one shown can aid in your explanation to the auditor on how you're in compliance. They say pictures worth 1,000 words, and they're not that long. Expand on this diagram, include any routers, switches, and perhaps even key cyber assets. If you want to get more detailed, great. But our goal here is to identify all the communications that are leaving the facility to the outside world. So we want to consider things like automatic generation control with your TOP or your third-party generation scheduler, control system monitoring by the vendor, maybe ABB or Siemens is monitoring your turbines, or a remote connection to a remote control center, corporate and employee VPN access. We'll also want to consider standard and cellular phone modem devices and Wi-Fi, and pull all that stuff on our diagram so that we've got a place to start from. This list of possible electronic access points into your network may expand as you investigate and explore your control system network. For example, I found many modems in my plant lockdowns, even though plant personnel thought there were none. So walking down and inspecting every cyber asset location in your facility, investigating and documenting the current setup is the recommended internal control to aid in documenting this requirement. As is having a detailed cyber asset inventory, it's not specifically required by CIP, but in my opinion, if you don't know what you have to protect by having a list of them, then you might not be protecting them all the same way or completely. The more information you have about your controls network, easier it's going to be to ensure that all devices were reviewed and accounted for. Once we know which devices support the electronic perimeter of the facility, we need to collect their configuration information. Explain how this device is limiting access. The evidence is partially found in the configuration of the device. The firewall has one or more access control lists and can be exported into an Excel spreadsheet. One of the things that we want to make sure that the configuration does is deny by default. And you see at the bottom in that blue box, the two entries at the bottom of each list is deny all other communication. That's what a firewall does by default, but we want to put that in the rules so that we can make sure that they're properly covered. This slide shows an excerpt from a firewall access control list. Far right column was added. So the firewall has an access control list. We export it. We put it into a spreadsheet. We add that comment justification column on the right. I want to draw your attention to a couple of the rules in here to show you where we're getting at with this only necessary inbound and outbound electronic access. So the first rule at the top, any source from the corporate network is allowed to get to that one IP address, 192.168.1.50 on port TCP23. So many of you may know TCP23 is Telnet. That's going to be not the best protocol for security. But the concern is the any. So anybody on our corporate network can get to this controls device. That's going to be hard to justify the way it's written. So it may either need somebody to explain it in that orange section, or it may need to be, the firewall needs to be adjusted and that rule changed down to just something else. So when you look at Rule 2 there, for example, the source is just two workstations allowed to get to the SEM server. You guys probably don't have SEM servers in your wind generation, but they're common in other types of power plant companies. And it's on a services RDP remote desktop. So over in the justification, we say that interactive remote desktop is required for monitoring and vendor access. That's okay. We're just justifying why we feel that access is required. It's limiting, and we say it's required. Good. Notice the next one down, 10.10.00/16 on row 3 there. That /16 represents 65,000 different IP addresses. Well, actually more than that. That's going to be, again, it's kind of like the any at the top. It's not very limiting. I would recommend that it be shrunk down to just the devices that need to access that machine. But you kind of start to see there's the reasoning for looking at the firewall rules and explaining or justifying why each of them is in there. The requirements stopped using the term direct access and now use the term communications. And the difference, the intermediate devices such as antivirus console or PySRAin now technically allow communications from a BES cyber asset out to the outside world. So what that means to us is that we really want to look at that perimeter, where the communication is flowing, and making sure that none of our BES cyber assets are in that rule set, in that access control list. And if they are, those ones in particular have to be looked at. So what documentation do we want to look at? We want to have, of course, a plan document that describes all this, just like we have a plan document that describes our physical security. I recommend a cyber asset list, although it's not required, specifically so that if I need to, I can identify things like where the modems are in the list, how the physical security is working, that sort of thing. But a list is a good control. A list specifically of your electronic access control devices. I've heard auditors ask for this because you're supposed to have electronic access control. Usually that's done with some kind of device or software. So you should know where they are, and a list is a handy way to do that. The diagram, we talked about extensively. Access control lists, the actual spreadsheet, and any vendor documentation showing how modems or any of this communication is expected to communicate. So an HMI talking to a database server, for example, might be on, a port, say, 2020, And we want to make sure that that not only have we documented it on our firewall that that's what's required, but that the vendor also said, hey, yeah, that's what we need to have. So if you have that documentation, great. And if you've done any walkdowns or any other kinds of control activities, those are good things to document as well and keep that. Now, not all of this documentation is going to be compliance documentation. Some of it's just going to be what we call back burner documentation or self-assurance documentation that we're good. But if questions come up at audit, that's when you pull that extra evidence out and say, look, we did look at that. Here's our list. You know, we did look at that. Here's our vendor documentation. Those are the kinds of things. This diagram or this spreadsheet excerpt is showing you an example cyber asset list. NAES recommends that the entity standardize on electronic host names in that gray column, the third column from the left. The first line, CRO HMI1, not station 1 or Bob station, but the actual computer or device's name. And then also label that exact same label on the device. So if I'm doing a walk down of the facility and I come across a whole computer room full of stuff, you know, there's a label on it that can be tied back to not only this list, but also your diagram. Try to keep the same naming convention all the way through with your devices. If your entity has more than one BES cyber system, the associated name can be identified in the second column. Normally, just the BES cyber system or the DCS for the entire plant facility is one system, but that's up to you. Showing which devices have external level connectivity through the firewall is a helpful cross-check in that column, that gray column towards the right, with what you put in your firewall rules explanation. Other stuff that you could put on here, like MAC address, IP address, that's all good for IT knowledge, and you'll see that. You see that down at the bottom down there for IT support, but that stuff's not explicitly required, of course. As mentioned before, drawings are very helpful in painting a picture of your perimeter and identifying what devices control access, and vendor documentation supporting each device, network service port, and use is great backup evidence. So a walk-down inspection of all devices is the simplest way to determine if a facility has a modem attached to something. Also a review of the phone bill, accounting for all line numbers that are listed. That's helpful. Realizing that cellular modems may be built into devices and won't have any physical phone lines. And you should have documentation on how each device or host authenticates with the user. The modem may be set to dial out only to a pre-programmed number if it's just sending data like a meter, or it can be set to dial back to a predefined number when somebody calls it and makes a handshake signal. Or modems may be remotely controlled by the control center or control room. In other words, have a AB switch, a physical switch that basically unplugs it from the wall, or that could be the other way, just unplug it from the wall. Access control of the BES cyber asset, like a username and password in the modem answering software is another way you can enforce authentication. It's helpful to keep track of these modems on your BES cyber asset list with a comment so that when auditors ask if you have any modems, you know where they're at and what they're attached to. Cybersecurity incident response has not changed in the since the last standard. So CIP 3-6 is the current version of the standard. CIP 3-7 is the one that we've been mostly talking about. Is coming effective on January 1st, 2020 for implementation. So you have to have these controls in place by then and this documentation ready. But between CIP 3-6 and CIP 3-7, this particular requirement didn't change. So if you were a BES facility before or are one now, you should already have this plan. You were required to have this back in April of 2017. But these are the elements that are required in the plan. So identifying, classifying response to incidents, how you're going to do that. The response is also mentioned down in 4.4, the handling of the incident, how we're going to do that. Usually it's get the malware off, or get the system restored from a backup. Those kinds of things are in the response section. But one of the things that I've seen a lot of entities miss is the determination section in 4.2. We need to have a part of our plan where we actually determine that this event that we're investigating is a reportable cybersecurity incident. So make sure you have all of these elements listed in your plan, including testing and including updated if need be. A cybersecurity incident, a malicious act or suspicious event that compromises or was an attempt to compromise your electronic or physical security, even though the title is cybersecurity, it includes physical. But that is a CSI, which means you would dust off this plan, follow it, respond to it, but it's not necessarily reportable to NERC unless it's compromised or disrupted one or more reliability tasks. And those reliability tasks are the ones that are listed in CIP 2. So it's somewhere in this plan, you want to have identified how you come to the determination that it's reportable, and then make sure you've gone in and filled it in. Some of the lessons learned we've seen. You must exercise the entire plan for the exercise to be valid. So you should have exercised your plan by now, preferably before April 1st, 2017, when it was required. But I recommend that you do that annually, even though it's a 3-year requirement, just so people are familiar with it. Just like Cybersecurity Awareness Craig was talking about, got to do it more often. Must use a reportable CSI in your scenario. This one I've seen lots of people where they say, oh, gee, somebody jumped my fence. That's not a reportable cybersecurity incident. That hasn't compromised or disrupted one of my reliability tasks. So make sure that your scenario that you're using for your drills is ends in a reportable scenario. And consider including Department of Energy and EOP4 requirements within the same plan, because they're all tied together. They're all reporting. There's our stuff about NAES, and I'll turn it back over to Craig.
All right. Thank you. Very good, Alan. Our last topic for this webinar, transient cyber assets and removable media. Back to Craig Reed.
Okay, thank you. All right, so transient cyber assets. Just for a definition, transient cyber asset is a laptop, a thumb drive, any piece of equipment that's going to be connected to your control network for less than 30 days. Okay, so the transient cyber asset portion has 2 different sections to it. Well, actually, Section 5 is made up of 3 different bullet points, 5.1, 2, and 3. But 5.1 and 5.2 deal with the transient cyber assets. 5.1 is saying is your internal control for transient cyber assets. So anything that you own that is a transient cyber asset, you're going to want to start off, you're going to want to make sure that you're using antivirus or whitelisting. Personally, I prefer whitelisting over antivirus. You want to make sure that all those devices are up to date. And you want to make sure that you have some method in place in your cybersecurity policy, wherever, where you discuss how you're going to mitigate the introduction of malicious code. So, how are we going to check that machine before we plug it in? Now, there are situations where you have devices that are not like a laptop. They're a actual device. It plugs in, but it's not a laptop. It's some other kind of piece of equipment. With those, you just need to make sure that they're on the latest version of the firmware to make sure that they're protected. Okay, so then transient cyber assets in 5.2, these are the ones that are owned by people other than you, your vendors. So how do you protect yourself there? Well, you have to make sure that your vendor has a policy, has a antivirus, whitelisting, any kind of mitigation, malicious code mitigation policy in place, and that it's being followed. So one thing that you can do, you can request a copy of their policies and procedures. Another thing you can do is before they can plug in a laptop or a thumb drive or whatever, you go ahead and review that yourself. You look at to see when their virus software was updated the last time, when a virus scan was run the last time. All this information should be in their virus software, antivirus software on their computer. Before they plug a thumb drive in, check it out, run it on, have a machine that you can test that thumb drive on to make sure that it's not infected. So the whole thing is making sure that you're protected before they plug anything in. Now, company I work for, we're a vendor to a lot of utilities and that kind of thing. We're instructing our people that if the utility or whatever doesn't ask them about their transient cyber asset, if it's if their antivirus is up to date and everything, that they suggest to the organization that they test it or that they look at it. So the idea is we try to help our customers be compliant by reminding them of their obligations. So then removable media, which is 5.3. So we need to be able to check thumb drives, USB drives, anything like that for any kind of viruses or anything like that before we plug it in. As I say, you wouldn't eat food off the sidewalk, so why would you ever plug a strange USB device into your computers without testing it first? Everything needs to be scanned before it's connected to your network. This is a kind of trust no one. Trust but verify, even if you want to go that way. But it's very, very important that we not just let somebody plug into our network. I do a lot of vulnerability assessments and that kind of thing, and I always make sure that my computer is checked before I do that. So all right, so to kind of wrap everything up here, so by January 1st, 2020, these are the questions that you need to ask yourself. Where are we now? How are we going to perform a gap analysis to decide where we are now and how we're going to get to where we need to be? Okay, who's going to develop the plan to help you work towards compliance? Okay, can you complete the awareness training and the transient cyber asset training within your organization? Do you have the needed materials to provide the training that you need? What will your incident response plan look like? Once again, we have to test that incident response plan, and at least on a yearly basis, maybe even twice a year, and especially anytime things have changed. Facilities change, employees change, that kind of thing. If you have a major employee shift, especially of people who are involved in your tabletop exercises, you probably need to think about doing that again. So then what about performing cyber vulnerability assessments and physical vulnerability assessments? Bringing in a disinterested third party to look at your cyber systems and your physical systems to make sure that there's nothing that you're missing. So these are the important things that I feel like you need to be aware of. And now I will turn it back over to Bjorn.
All right. Very good. Thank you, Craig. Thank you all the presenters so far. So that's the presentation. I know that was a lot of information in a short amount of time. Hopefully that generates some questions for you. So if you have some questions, please start typing them in, and if you can specify which of these topics your question relates to, then I can help direct that to the speaker that you just heard from. As a reminder, these questions, I will read them as they come through, so feel free to ask that question that you're maybe a little fearful to ask, but putting your name or company out there. This is going to be completely anonymous here. All right, so Neil, I guess a reminder to all the presenters, you probably went back on mute, so why don't all the presenters go off of mute as these questions come in. All right, Neil, question for you. Discuss the locks on the control room and whatnot. What about the power to, let's say, the SCADA rack, whatnot? How do you address, what do you consider for the mechanical room that would power up the SCADA system, for example?
Well, if the equipment's in the control house, it's obviously protected inside. We also put a sticker on the breaker, on the breaker inside the control house that controls the card reader. And also we do have some equipment back at our operations and maintenance facility. We have that in a separate closet, in a separate rack, and that entire closet also has a card reader on it to control access.
All right, thank you, Neil. I guess I don't remember which topic this was, but the red face, oh, just lost it. All right, Alan, question for you. You mentioned the modems. What are your thoughts on UPSs? And I think a lot of these UPSs now are smart enough to notify us of power outages and whatnot. Would you consider that a modem?
Depending on how it's communicating, it may very well have a modem in it. Depends. It's probably plugged into the network more than likely. But an email from your UPS is, you have to determine whether or not that device is a bedside asset to tell if it's in scope or not. But it's probably, if it's plugged into your network already, it's probably behind your electronic control already. But just identify where it is in relation to your firewall. So you only have to have one firewall protecting your facility. It doesn't even have to be at the facility, but the communication that leaves the facility has to be protected. So if that's just sending an email out from your facility to your email server, and then it comes back to your users, that's probably not going to be a problem. Brian, you still there? Did I lose everybody?
Oh. I just told you guys to unmute, and guess what I did? Joseph, question for you. I think this one's for you. How many cybersecurity incidents do you see occurring in a typical year?
Well, there's two answers to that question. There's the reportable events, and there's actually a cybersecurity event. Something that might be dangerous or something that might be, actual, something that Hollywood would want to make a movie out of. Of those, very few. The reportable ones, yeah, just based upon the rules, there's things that should be reported because you never know if what you're reporting, even though it might seem small and minor to you, when it gets aggregated up amongst all the entities across the country. The ESI's Act looks at that stuff and correlates that, and it could be a broader trend. You know, there could be a large-scale attack going on, and you're just seeing one little piece of it. So there's the reportable, and then there's the things, like I said, that would make a great Hollywood movie starring Bruce Willis. Very few of those, if any. But reportable, just like any type of event, like an OE 417. You know, there's a lot of things that are reportable that aren't necessarily dangerous or of much note from the broader perspective.
Thank you, Joseph. This one is either for physical or electronic control, so we'll start off with Neil. Neil, would these standards apply to solar facilities as well in a similar fashion?
Well, if the solar facility is 75 MVA interconnected at 100 kV or higher, then, you know, it would fall under the same.
I'm assuming that's the same answer from Alan.
You can assume away. If you're waiting for me to respond, I'm sorry.
How are you handling Met Tower concerning electronic access? So I guess still with you, Alan.
Yeah. Again, the individual components of a power plant are still going to go through the perimeter to communicate out. So that's why I recommend that you focus on those perimeter points. So any communication is authorized if you feel it's authorized. But is it limiting? That's where we want to address that in the rules to show that it's limiting that communication. So a good example is in the old days, firewalls, you know, you think of two sides to a door, maybe a bouncer in between there, and one side is protected, it's the safe side. Well, in the old days of firewall rules, you know, those devices that were in that protected network could talk to anywhere on the internet. They could just go out on the internet, and there was no outbound rules stopping them. That's bad for security today because, you know, that's allowing command and control. Well, it's still allowed, but it was an unrestricted command and control could be controlling those devices in there. So you just want to make sure that the communication that is going through that firewall, is going through that perimeter device, is limiting, and it should be in there, right? It's not some rule that was put in there 10 years ago, and gee, you know, that device changed, and now it's not necessary. Just make sure that those rules are in there, and they're supposed to be in there. Does that help?
Yes. I think this was from Craig's presentation. Correct me if I'm wrong, but what are the red face tests you were referencing?
That wasn't from me. That was from, I think it was from Joe Baxter. But basically, what was being said there is, if it's going to embarrass you, if somebody finds out different than what you tell them, then you shouldn't. You need to just be completely honest in your documentation, in your reporting, and you know, not give them any reason to dig deeper into stuff that you're going to have to embarrass yourself by saying, yeah, we didn't do that the way we were supposed to. So if you didn't do it right, admit that you didn't do it right.
Joseph, anything to add to that?
Yeah, it's just most of the times when I've yet to really see anybody at an audit where it turns out that somebody's trying to play games or that there's anybody trying to play. Yeah, people might be playing fast and loose, but they're certainly not in our industry. There may have been one time or two when an audit where somebody was trying to pull the wool over the auditor's eyes, but for the most part, our industry is very honest, very ethical, and there just isn't a lot of that. But nonetheless, there are times when you're thinking about, I've got two ways of doing this. There's the easy way that I hope nobody asks me about, and then there's the slightly harder way or maybe more expensive way that I can be very confident in. You'll thank yourself in any type of audit in the future if you go ahead and spend the extra effort or expense and do it in a way that you can absolutely be confident that you've got quality evidence in an audit, and you did what you said, and you can prove it.
Next question. I think this one will go to back to Alan. Do you consider meters, low side, high side, as BES cyber assets to protect? Breakers.
The meter. Yeah, the meter typically is not, but if it can communicate on a network, then it's a cyber device. It depends on what you're going to do with that meter, in my opinion. So if that meter is sending data to the control room operator, and the control room operator is making decisions that impact the plant based on that data, then yes, I would bring it into scope. Because if I hijack that meter somehow and started sending false data to the control room operator, that's situational awareness. That's one of the bros in CIP 2, and that can definitely impact their decision making. If the meter is just data that's going to your TOP on your megawatt output, then that doesn't impact our plant. The TOP might be concerned if it's been hacked and sending bad data, but from a plant perspective of the reliability functions that we're required to protect, that's not one of them if that data is not being used by us. So it kind of depends.
I think this ties pretty well into that. I'm going to send this one to Joseph. Although cyber vulnerability assessment is great to do, not required unless you're a high-impact facility, correct?
Vulnerability assessments are for medium and high.
Ditto.
There was a mention of cyber locks. I think that was you, Neil. We give an explanation of what a cyber lock is, and I'm going to add to that. I guess I'm not that familiar with cyber locks, so could you explain that? How do those work in the case of a grid outage?
So cyber locks are, it's a key system where there's a chip inside the key, and they can be programmed really any way you want to. You can set dates for them to expire. You can create subsets so that they only work on certain locks. One of the big advantages, if someone leaves your company or loses a key, you can recode all of the keys and the locks. You don't have to replace the keys. You don't have to replace the cores. We've been using them I brought them into the company 15 years ago, and they've been working great. In terms of outages, they're battery operated. They're not affected by any type of electrical outage.
Thank you. Back to Joseph. Have you seen any guidance regarding what will be examples of self-reports after January 1st, 2020?
Guidance for making self-reports or guidance for how they are dealt with? They probably have a hard time answering that. So let me answer it both ways. No, I mean, as far as guidance for self-reports, there are, if you do a search for the NERC on the NERC website, there are probably a guide on self-reports. But the reality is the earlier the better. In any case, you'll get more credit for being, doing a self-report earlier versus it's far worse to try to do it. There are people that try to do self-reports during audits, and quite frankly, that's not a self-report. That is actually a finding at audit. But if you're in, during the audit period, if you've already got, if you're doing a self-report and that self-report is generated because they requested a sample of evidence from the audit period. I mean, you got an audit notification letter, and it says we're going to sample these things, and in the middle of you looking through your evidence because of the things that they sampled, that the audit notification caused you to have a self-report, you get a little bit less credit for that. So earlier is better. When you find it is the right time. A lot of entities have a policy or a procedure in place where they only give themselves a short amount of time to actually discuss whether or not they self-report. A lot of self-reports are dismissed as, without any type of non-compliance found, or potentially if it's something small or something easily fixed or already fixed. A lot of times it's what they call find, fix, and track. I'm not really in enforcement, so I can't, give you any more details than that. But earlier is better.
Thanks, Joseph. If that wasn't exactly the question that you thought you had asked, please ask again, maybe in a little different way. Joseph, I think sticking with you, and I don't know how you're going to answer this one, maybe safety in numbers. Given the distributed nature of wind energy, does adding more wind to the grid increase or decrease the risk related to cybersecurity threats? I guess safety in numbers in that there's 50 sites and one of them goes offline for a cyber incident, you still have 49 versus maybe a larger plant with a different fuel technology.
Right. There's a couple of different ways of looking at it. Generally, disaggregation strengthens. That's why a lot of the larger baseload plants, the coals and various things like that, they disaggregate the units and segregate the systems out so they can get down back into the lows. We support that because it increases the attack surface. If a bad guy is hacking into one thing and gets control of 1,500 megawatts versus they have to hack into 4 separate things to get a hold of a couple of 300 each. That increases the lift as far as the attack, the attacker. It broadens the scope and the attack surface. Now the downside to that and the countervailing opinion is, but all of these control systems are exactly the same. So just because you disaggregate it, if you use the same passwords on all 4 systems, 300 times 4 is 1,200 megawatts. If it's easy to get into all 4, as easy to get into all 4 as it is to get into one, you're not really doing yourself any favors. So just bear in mind that the purpose of keeping things in the low and the purpose of this protection is to slow down, prevent, retard types of attacks or misuse. So as we add, follow good security principles. But theoretically, when we add, it increases attack surface. Now, putting them on there at all, well, that's just something that the requirements came down. That was a federal level decision. So we don't really have any choice about whether or not we put them into the CIP program. So when we put them in the CIP program, we just have to make sure that we're not just following the regulations, just the requirements, but also keeping in mind good security. Cybersecurity really is the key. And with the current version of the standards, if you fulfill good practices on cybersecurity, you generally are fulfilling the CIP standard requirements.
Joseph. Question for Craig. Craig, can you explain a little bit more about what whitelisting is?
Yes. Whitelisting is, basically what it is that you tell the systems what software is allowed to run. Instead of an antivirus software program where it's looking for virus signatures and that kind of thing to block software, you're saying programs A, B, C, and D are allowed to run on these computers. If programs X, Y, and Z try to run, they will be stopped. So you're only running approved software, approved systems, instead of just trying to block the bad stuff.
Thank you. Back to Joseph, clarification on the question of the self-reporting. What would you consider self-reportable? Finding an open RDP hole in a firewall, or asset, or asset owner has a built-in direct data feed to the RTAC? Looking for examples of what would be self-reportable.
Well, it's not the simple answer. It's actually the only answer from our perspective is that anything that does not strictly fulfill compliance is reportable. While the standards are better and there's not, in terms of enforcement, what was used to be considered zero tolerance, In monitoring, it is zero tolerance. We do enforce strict compliance. Now, obviously, there's some gray areas here and there. Generally, it's better to self-report and be told, that's nothing, never mind, and it be dismissed, than to not self-report and have it found at audit and it turn into a big deal. I hope that's helpful.
This is.
Hey, Bjorn, this is Alan. I'd like to add something to that. In my assessments of power plants, I often find connections such as that, where a connection goes off to a router, off to an owner, or to the TOP, or even to the RC, and because those are trusted point-to-point connections, they often do not have any access controls on them. And in my opinion, that violates the standards. So if you haven't found those and addressed those, put some kind of electronic access control on that connection before January 1st, 2020, then in my opinion, you would be in violation. And then you would have to self-report and mitigate that. But that's why it's important to not waste time this year, is to make sure you've identified all that, those connection points, and make sure there's some kind of electronic access control there on each one.
Hey, Bjorn, this is Leland. I was just going to add to that a key point that Alan made is that, self-reports wouldn't be required until January 1. So if you find the issues now, you can fix them before self-report's needed.
Exactly, and that's why we as ESIG user group felt October was a little too late to get this information out. So thank you, Leland. I think still with you, Alan, do you believe firewalls are more reliable than routers for being EACs? If so, why?
Absolutely. For one reason, a router doesn't log traffic. So, the connections that, the information that we might use for a cybersecurity incident investigation, router's not going to give you any. So I can't go to the router after the fact and say, gee, this IP address from China came into my network. That's not there anymore. With a firewall, you're going to get that data, provided the device has enough hard drive space to save that log data for at least a fair amount of time, say 90 days. Most incident response investigations, they might be years down the road, and that data would be long gone. But a firewall is better for that device. Firewalls also have additional features like antivirus scanning for communications coming and going. Some of them have threat monitoring, so they can look for attacks. So there's certainly a lot more advantages to putting a firewall in than relying on a switch or a router's access control list.
Thank you. Craig, is vendor-level whitelisting enough for compliance?
Vendor level, no, I think it needs to be, anything that you're running needs to be whitelisted, not just the application softwares that you're running.
Well, I've come to the end of the questions. Give it a little bit longer and see if there's any more. In the meantime, while we're waiting to see if anything does come back in, I'd like to personally thank each of the presenters. They had significant effort in putting their slides together, and I really streamlined them into what they were allowed to say for time's sake. Again, you'll be receiving a copy of this. Anyone that's signed up for this webinar received a copy of this. So if you need to know more, and you've got 6 months to figure it out, reach out to these guys. They're a wealth of knowledge on this topic. If you like this kind of format, this webinar was open to anyone, whether you're an ESIG member or not, and want to continue these types of discussions, maybe on different topics. Check out ESIG. It provides the opportunity for everyone that's on this webinar to say, hey, have you seen this problem? How did you fix it? Or don't try this as a method to fix it. So can we meet twice a year? Check that out if you want to have other conversations similar to this one. We did get 2 more questions in, so let me get to those real quick. Meters or med towers included as BES cyber assets. So are meters or med towers included as cyber assets to the bulk electrical system?
Yeah, we already addressed that one.
Yeah. Let me throw in my layman term definition for how I consider this is if I look at a device, if there's a device there and I, in my head, rip it off the wall or off the desk and throw it away, destroy it, did I lose the ability to control generation or limit generation, control our turbines? And that's kind of my way of looking at this, and you guys correct me if this is the wrong interpretation of that, but a kiosk that I've destroyed does not affect my generation, then that's part of my reasoning on considering something a bulk electrical cyber asset. So think about that meter or med tower. Sounds like some sites have the med towers that report that's part of their ability to generate at a certain level. For me, that's not the case, but maybe for you it is. So even the same asset, I think I mentioned several times, list the asset and then your reasoning for including or not including it. Any other thoughts on that? All right. Well, that's the end of the questions. Again, thank you for spending your time with us on a Friday. It's a sunny Friday here. Hope for you as well. Again, check your email for the recording and this presentation. Have a great weekend, everybody.